next presentation is conversational search with large language models. My name is Andrei Lopatenko. Currently, I'm director at Neuron 7 AI. And basically, I'm talking about search. I'm in the field for 20 years. I started in early Google, built search for Google, for Apple, for Walmart Labs, eBay, and several other companies. There is a lot of hype about AI and search, as you know. Like, there are a lot of successful companies like Perplexity and many others. There is a lot of AI search. There is a lot of conversational search. What I believe makes conversational search and why it is different from a generic AI search. I believe to make a really good conversational search experience, it's very important to have long-term memory and multi-turn understanding. So typically, if you want to provide smooth experience, you must give to customers ability to not just one search query, but to ask several queries and clarify their query in terms of multi-turn experience. It's very important, not just if you go to e-commerce site, for example, and you can search products directly on real estate, what we built in Zillow. Also to give opportunity to ask generic questions to support their search, to support their decision making. Of course, it's important to provide natural language understanding such that customers can ask complicated queries. Search is not only reactive, it's proactive. It's not only gives you answers, it's also asks you questions, helping you to go to yourself, to resolve your goal. And it's task solving ability. Typically, people now from search, they don't expect such that you just ask query and get results. Actually, you can describe much higher level, for example, what in Zillow we built. If you're looking to get a loan, it's not just you're not just looking for a loan officer. You may ask a generic questions I want to finance my house. What should I do? And system help you through define multiple different steps, financial planning, but also to find your loan officer and the best loan option for you and so on. What is search engine trends? If you look what's happening in big search companies, including Google, Bing, Perplexity, many other. So typically before our industry was focused on one query results. Of course, there were some conversational practices, but not that much. Was very much optimized for high performance. You want to process 1 million queries per second because you have millions of users, billions of users sometimes. You want to give answer within several hundred milliseconds. And now people understand that search can solve much more complicated problems. It can provide deep understanding of queries. It can provide more relevant results. It can support a complex multi-step task, not just answering current question. It can provide richer context information, and people are willing to tolerate little longer time to get all this better search experience. Of course, when you ask basic question, you still expect result very fast. But what we see now, people, especially a lot of searches for vertical domains, when you want to find better house for real estate, right? You can wait several more seconds if it will save you a lot of time doing touring of houses. And for many other domains, the same. So people can tolerate now latency, delay to getting much better results and much better experience. What I believe, what are fundamental, I would say, not model level, but more search component level, components which solve this. One is, of course, search clarification and query clarification, such that search system can understand and clarify your query when it's not clear. Deep query understanding still required. Semantic search, deeply understand your query. Better re-ranking, of course, is important. Summarizing at scale, so it's not only what results you found, how to present them, how to help your users to go through your search space. Answering complex questions becomes important, not just direct, you're coming to e-commerce site, you're not only asking, I'm looking for lawn mowing. You ask I want to care about my garden. What things should I buy, right? And also measuring evaluation is another important. So it's very short time. I have only 25 minutes. Each of these topics deserve 1 hour to go to technical details. So I give high level overview of some of them. Search clarification. Frequently you see when now a lot of RAG-based search architectures launch when people trying to create conversational search experience. Search clarification is frequently neglected, but it's a very important part of search experience. So from my experience building search engines for Walmart, eBay, in e-commerce, around 30% of search sessions, they actually involve one or another type of clarification. Frequently through navigational panel, it's just one type, but as you see, like for vertical domain search, clarification is very important and many users want to have it. And it significantly impacts also sessions. So when you see when people clarify query, actually sometimes it's double digits, or like in my experience I saw like up to 20% improvement in conversion if you make a good clarification, if you help people to find their searches, what they're looking for through clarifying, through more proactive system engagement. Actually it's very significant improvement in conversion and also engagement. So search clarification is not something to be neglected. Like what's important, I saw some launches when people launch search clarification just asking LLM, please clarify this query. It does not work well. There are very different type of clarification needed, and you need to fine-tune system and fine-tune not only as fine-tuning of models, but design multiple different models to do them. Like, for example, and here give some papers which provide like what work was done, but there is like I will share at the end. There is my repository of generative AI and LLM for search and personalization and discovery systems. You can find more sources there. So there are very different type of clarification. One, when you ask a broad query. So, for example, you come to a e-commerce site and you ask shoes, right? Very generic query. System has to help you to drive. Are you care about this type of shoes or this type? It can be by gender, it can be by season, it can be by type of shoes, it can be by size, many other things. So broad queries, driving them to more narrow queries, like very good customer experience and also very big improvement in conversion. Because people now, they don't find something immediately, they go to your competitor website. Multi-intent queries. There are queries which have multiple different intents, and I saw this in every domain. Like, would you do real estate search? Would you do e-commerce search? There are multiple different intents in the query. How to help users to provide information, what intent they're looking for. Another very important and requires special tuning of your clarification system. There are queries when it's very hard to understand what user wants, and clarifying what the real intent is another important. Query detalization, it's encouraging users to refine or elaborate queries, improve task alignment and conversion likelihood. And there are many different types of this query detalization. So for example, for e-commerce search, it can be about getting particular attribute about this item. For real estate search, what we've done in Zillow, it can be about more detailed information about your type of search for the house. And it's true, like in every vertical what I build, we always see it's like this query detalization helps a lot, but also it requires, don't expect, there are multiple different techniques, not just LLM on its own. Sometimes you need to analyze a set of documents returned, create clusters, drive users through them, or understand type of query, understand what typical attributes for this product, maybe many different techniques. So it requires building quite big stack, but big improvement in conversion and business impact and user impact. And there are also, like, for example, when you want to drive users to goals. So people come, let's say you're doing real estate financial search, right? And they want to get a loan. So it's like part of search to give them a loan offering, or loan officers is only part. How to drive them to task completion, decompose search into multiple different subparts. It's another big impact factor what makes much better search. Another important, of course, search clarification is how to estimate this. There are several techniques. There's a paper which estimates them offline, but of course, what you really care about, what you do real evaluation on search traffic. How frequently people your customers use clarifying elements. After using this element, does it improve final conversion? Does it improve final experience? Does it help them to resolve tasks? And so on. And so search clarification is big impact feature. So query understanding, next feature. Everyone is using now RAG type of solutions, and they're of course very powerful, but again, they don't solve all problems. And for frequently, if you want to make the best search experience, you build like what currently like keyword search or BM25 type of search. You still want to have a detailed understanding of query. You still have a traditional information retrieval items working together with embedding-based solution, but also retrieving a lot of information which frequently embedding representations don't catch. And even if your search is based on embedding representations, embedding don't typically they catch very well textual relevance factors, but they don't catch like other factors which are important to improve customer satisfaction, customer conversion. Like for example, if you're building e-commerce search and people looking for, let's say, mobile phones, they're looking for recently released items, not just any mobile phones from textual relevance. If they're looking for pillows or furniture, they don't care much about recency, right? And query understanding catch these multiple dimensions which go beyond textual relevance. So there are a lot of factors which query understanding significantly improve experience of your customers. And currently, what big advantage of large language models now with LLMs, you can build query understanding much faster than it was even like 5-6 years ago when we built this like particularly trained NLP models. There are different types of NLP models. Takes quite a long time to build data set to train them. With LLMs, you can do much faster and frequently even better. What the challenges with LLM-based solutions for query understanding, of course, is high inference cost and latency, right? Because query understanding you want to run for almost every query, and assume you have a system which process sometimes in the peak load like 1 million queries per second. And of course, users expect very fast reply to the answer. So that's why LLM creates some challenges. And what are good solutions? A multi-tiered approach, such that for simple queries, you have a certain simple NLP models which work much faster, much cheaper. You use LLM only when they don't work. Basically such tiered approach allows you to build, and then you can also create several different optimization layers. So for example, semantic caching, such that if you already understand this query, and then you can detect similar, like another query which is very similar to this, you already use this semantic representation, semantic cached representation. You don't need to run LLM again. There are multiple different optimization factors, and they're used quite actively to build efficient query understanding systems. And again, query understanding there are multiple different layers inside. Like for example, you want to semantically parse query. When people come and let's say you're a real estate search engine, so I'm looking for a house with 5 bedrooms closest to highway within half of hour driving distance from Seattle. You want to parse these chunks, understand size of the house, location, geographical location from the proximity to highway, semantic parsing. Generating query variants helps in many cases when you can create similar queries and use them for retrieval or like a generalized item. Like there are multiple different options how it can improve user experience. Long-term query rewriting for for queries which are very long, typically in sense of, and they go like very rarely made. How you can understand them and how you can find generalized queries. There are many other like options what you can do. Query classification, given a query to understand what like part of your catalog or what part of your item, right? What are hidden intents inside this query? Especially like, for example, if e-commerce frequently use hierarchical representation of all items, but there are many others, like it can be integrated with graph. Decomposition query into semantic chunks, detection of similar queries and other very important techniques used for many types of building better search experience. For example, frequently use historical signals for queries, and you can do much better improvement by looking into similar queries. Embedding models. Of course, very important part of any search application is using embedding models, and typically you build embeddings and you use re-ranking. There are a lot of embedding models on the market, you can use them. What I found, frequently they're not enough. There are a lot of leaderboards, right, and they're good for generic, like there are several big benchmarks, but once you go to your particular, is it real estate, e-commerce, what we're doing in Neuron 7, service resolution search, of course, generic models don't catch all particularities of your search requirements. And for this, you need to build models which can understand, and you need to fine-tune models for this particular type of experience. And of course, embedding models training is quite big task, but it gives big benefits because once you have models tuned for your customers, tuned for your task, you can provide much better choice. And what I found from my experience is fine-tuning of embedding models is quite strategic improvements, which gives you much, because you have multiple competitors in any business. Everyone can use open source models, but fine-tuned models is something which can search like your task, and they can give a very significant advantage over competitors. So there are a lot of choices, on the selection of embedding models, on training them. It depends, and there are multiple different type of embeddings. Do you want to use them for retrieval, for classification? Sometimes you need to have fine-tune multiple different models for different tasks, but all of them important for search, and all of them give a quite big boost for your improvement. Proper model very important to start from. Select a correct loss functions. There are plenty of them if you look into sentence transformers, and there are good libraries supporting this. Sometimes you have to write on top of this, but like sentence transformer is good library. And again, there is a big selection of embedding models on the market. Some of them on the cloud, some of them open source. So there is quite a good way to start. And what important now, there are a lot of also like multilingual embedding and also the ranking models. So like if you consider 5-6 years ago, you want to build multilingual search, let's say you want to cover Japanese, German, Italian, other languages, it was very hard task, very little of models and LP models were available. Now there are a lot of very good multilingual models, which both embedding and ranking, which help you to build multilingual search. Typically, if you want to make a good search experience, you deploy multi-stage pipelines, right? Vector-based retrieval is good for fast retrieval, but then you want to rank for better relevance. And for this, you build re-ranking models on top of it. It's like when you're selecting a model for re-ranking, there are several factors to be considered. Of course, like as you see, there is a very big selection of models with different window size, with different parameter count. Of course, overall performance is important. Language coverage, as we described, multilingual search, re-ranking accuracy, and there are multiple different tasks you may use. Like, of course, textual re-ranking is the most important, but depends on your system. There are good models for code re-ranking, for tool retrieval, and so on. Like typically, you look for generic search benchmarks, like how model behave on BEAR. There is a good re-ranking leaderboard, kind of gives you a good idea generically how good this model is at high level. But then you want to test them on your task, of course. And re-rankers, again, they're kind of giving final word in your relevance. And you can tune them. And you use typically there are different ways. Of course, you can do offline relevance evaluation, but what really good signals are using your customer feedback and implicit feedback like clicks, after click behavior, refinement, abandonment, rent. You have to convert this to relevance factors and then tune your re-ranking model, which gives big advantage in relevance. And there are multiple different models available for re-ranking, both commercial and open source. So there are a lot of to use and start from. There is recently some hype about instruction re-rankers, such that you can give like to LLM additional instruction, please rate documents of this type higher. A lot of hype, but I find them not very useful because typical, like if you want to tune your re-ranking to your users, is like such kind of manual reference, this type of document is better, it does not work. You need to learn much more subtle signals, and for this fine-tune re-rankers, or also you deploy some more like conversion-oriented models on top of textual re-ranking. And second, actually, option works usually even better. And of course, like once you retrieve results, you want to summarize and represent them. Also frequently overlooked, but it's very like what I found, again, from my experience in real estate, e-commerce, and other searches, even long time in Google before LLM, like representation of results can significantly change customer conversion, customer satisfaction, how many results are used. And now with LLMs there are even more factors. You can, of course, much more improve representation, but there are much more risk because of hallucinations and other factors, right? And typically there are different things you can do here, right? One is, of course, representing information what you retrieved from your search-based index. But frequently to create a good results is not enough. You have to integrate with external sources. For example, in real estate, you can retrieve information about houses, but then you want to enter information about locations to present this better information because locations is very important for customers. There are other also information, not just about locations, but about, like, let's say, for real estate crime level or air pollution or something else, right? And the same for e-commerce or anything else. There are a lot of additional information which you want to enhance your set beyond what was retrieved by your RAG-based architecture, and it helps to create much better representation to the customers and improve their search experience. And there are multiple different techniques. Like, for example, you can integrate, there are a lot of good techniques about when you create hierarchical level of chunks. One is used for, like, when you do rank-based retrieval, you use low-level chunks to define most relevant documents. And the narrow chunks are the better, but they're not good. Actually, small narrow chunks are not good for generalization. You want to extend them with high information to provide more information to present results to the customer. There are different techniques here. And like, for example, graph rags, there is when you want to create more generic representation of information using rag-based approaches and then you, retrieve information. Of course, you want to have a summarization focused to satisfy for this query focus summarization. There are like three organized retrieval when you create a hierarchy of chunks and you use them. And there is a very good survey of different techniques how to create this type of representations. Very important, of course, once you use LLMs to create representation, hallucinations arise. Right? I found them even for very narrow task when you have very detailed prompt and very clear query and very clear documents, right? Even at that stage, not just some big like solving task, but very narrow generalization task like summarization. Even when you ask LLM summarize, frequently just simply summarize, hallucinations arise. And for some type of experience, it can mean really bad customer experience. Think about like maybe generic e-commerce search is kind of tolerable, but if LLM change price of item, not good, right? Or for financial search, if it invents some facts which can make incorrect decision, help you to influence you to make incorrect decision. And what I found for some type of building LLM-based conversational search, hallucination creates very high risks, and there are several different techniques how to do it. There is pretty good paper from Google DeepMind, safe, and actually it's from DeepMind, but it's very easy to implement this technique. So you basically use LLM to decompose generated text into atomic chunks, so it's really like kind of syntactic processing of the text. But then you verify every fact of this text versus your database, versus your index. And what's good here, you can also like understand by type of the chunk, like here you can tolerate some hallucination, at least you don't need so strict verification. Here is financial information or some compliance information, you need very strong verification. And there are other techniques, pretty good paper from Amazon about how they do. So it's important hallucination avoidance when you create conversational search discussions. So we're close to the end, and I wanted to emphasize, maybe remember one of the first slides, there are many other big important topics. So deep research, I see is coming, not only will be like for companies like OpenAI, but actually when customers want to buy something from you, right? Or make some transaction or do some booking, just direct search is part of this. They want to do research. Frequently now they leave your system, go to Google and then leave this, and having deep research on your side will be something important, and this is one of the next parts of conversational search is having deep research as a part of search. Search integrated into transactional experience. Typically now all search engines are on top of transactional experiences, but certainly you want to search like a company help you at every step of your transactional journey. And multimodal context understanding. Now it's very easy to process text, image, voice, many other data, and use them for your search experience to significantly improve your topic. And I wanted to recommend, so like I have two compendiums where I collect a lot of data and survey them. There is a lot of papers. One is about using LLM for search recommender personalization engine, and another for LLM evaluation. Yes, thank you very much. I think we have 1 minute for questions. Thank you very much.